free training provided by the HVAC School podcast is made possible because of the generous support from our sponsors, Testo, RectorSeal, and Carrier. Condensate overflow switches are very much under-considered in both maintenance situations, service calls, and in installations. Technicians, they get used to installing them one particular way, and then they want to apply that rule to every single switch that they run into. And different applications require different types of switches, even in the Unified Mechanical Code. So James Bowman and I talk about that a couple episodes back if you want to hear about that. But RectorSeal is a leader when it comes to condensate overflow switches. They have the Safe T switch, they have the Easy Trap, and they also have the AquaGuard lines, all under RectorSeal. And they all make different products that serve different purposes. They have products that have the trap already installed that you can clear out and you can see the entire trap. Even with the safety switch, the SS1, which is a switch that we've used for years, they came out with a clear bodied version so you can actually see what's in the switch, which is pretty cool. We use a lot of the SS2s, a lot of the SS3 pan switches. They just have a really wide, broad line. And when you look at AquaGuard has some really neat, innovative products. They have one float switch that you can actually unthread the cap from the bottom in order to get the water out and check the float, which is a nice design. So there's a lot of different products that you can get through RectorSeal in the condensate switch category. But the one thing that I want you to think about is next time you open up one, so say you open up a safety switch, the SS1, read the manual because you'll find some things that you maybe didn't know. Like, for example, that the float is adjustable. You can actually adjust the height of the float to suit the application. And that alone makes a big difference in application to application, situation to situation. And so whether you're mounting it horizontal, whether you're mounting it vertical, whether you're mounting it in the primary drain or the secondary drain, whether you have pitch on it or not, these are all things that are going to help you decide which one of these products you choose. So check out the full line of products at RectorSeal. You can go to rectorseal.com to find out more. That is the Easy Trap, Safety Switch, and AquaGuard. Testo is celebrating 60 years of high-quality instrumentation with their best-in-class fall combustion analyzer promotion. There's never been a better time to get a high-quality Testo combustion analyzer than right now. This offer is for a free 770-3 meter, the meter we've talked about a lot on this podcast with Bluetooth and direct power reading and inrush amps and many more great features. You can get that meter for free if you purchase the Testo 320 or 330 series of combustion analyzers, or you can get a 745 non-contact voltage sensor if you purchase the Testo 310. This is a limited time offer, and you can find out more by going to hvacrschool.com/fall promo, which will take you to the Testo site where you can get the form to fill out. You do need to hold on to your receipt from whoever you purchased the combustion analyzer from, but of course we suggest if you don't have a local supply house that stocks these, you can easily go to TruTechTools.com, TruTechTools.com, and use the offer code GetSchooled, and you'll get an additional 8% off. Then just save your receipt that you get from TruTech Tools, go to hvacrschool.com/fall promo and fill out the form, and you will get either a free 770-3 meter or a 745 non-contact voltage sensor from Testo. Testo, 60 years of excellence. Perfect for testing, perfect for service.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
And now your host, the man who is actually a giant nerd, but wants to be accepted by blue-collar tradesmen to fulfill some gap in his soul left there by his father, or his mother. It's definitely not just because he's a weenie. Brian Orr.
Hey, what do you say? This is the HVAC School podcast. Thank you for being here. Thank you for listening to the podcast. This is part 2 of the conversation that I had with John Chavez about VRF and ductless. If you haven't listened to part 1, then go back and listen to part 1 first. Otherwise, part 2 is not going to make as much sense. It's not going to be as complete. So here we go, part 2, John Chavez on VRF and ductless. Number 8 is power in and power out. I'm interested in this one.
Yeah, so to demystify the troubleshooting aspects, If you believe that there is a component failure, to discover that, first you want to make sure that you have the proper voltage going into the unit on the terminal strip, okay? Then you want to make sure from the terminal strip to the board or boards are getting the proper voltage. If the board isn't lighting up, you're going to check the fuses, because there are going to be some glass fuses on there, most likely, little small fuses. And if those fuses are good and you don't have any lights and your system isn't operating, well, then it's probably the board. But if a component is not activating and the board is active and the light and the LEDs or what have you is flashing, then you're going to make sure that the board is giving voltage out. You see, so if you have power going in and you don't have power going out to the component, what's the problem?
Inputs and no outputs, then it's what's in between.
That's right. Now, this is a real oversimplification, because the condenser fan motor is usually going to be DC voltage with a 5 or 6 wire connector, okay? You have 5 volts DC, 12 volts DC, you have communication volts usually in DC, you have the condenser fan motor volts DC, then you have compressor, which is going to be VAC. You have to look in the service manual to discover what you're looking for. Because if you're just testing just a test and you don't know what it should be, then it's nearly pointless, It's better to know what to expect and then do your tests. Power in and power out.
Got it. Yeah, pretty straightforward. And that's part of not being overwhelmed. I think this is the thing technicians get in most kind of overwhelmed by, is looking at all these boards. But most manufacturers, at least of the higher quality products that are on the market, the Mitsubishis of the world, they're going to have some pretty good documentation that's going to describe to you, what the different voltages should be at different points, so that you can kind of walk your way through the system with a voltmeter, because that's largely what you're going to be doing. You test a lot of sensors with an ohm meter, but a lot of what you're doing in diagnosing a ductless system is really just walking through the system with a voltmeter.
Yeah, and having a true RMS voltmeter, it's something of quality that has at least 600,000 ohm range and both DC and AC voltage. That's the tip, and if you don't have a DC meter, you can buy one at Home Depot for $30.
Yeah, we also rode all the technicians out on a rail who didn't have good quality true RMS meters, so we should be fine with that as well.
Those are the electrical tools that you need and their ranges. But going into number 9, which is go, no-go temperatures, discharge air temperatures, the leaving air temperatures you should be looking for under AHRI conditions, right? 95 outdoor, 80, 67 indoor. You should be somewhere between 40 and 50 degrees coming out at the discharge of the ductless unit. That's pretty typical. The pipes can get as cold as 37 degrees, before going out on frost protection. So this is why you need to insulate the condensate lines, And there's been times where I get a phone call and there's puffs of smoke coming out of it. They're complaining they don't know what's going on, and it's actually just fog. That's how cold it's going.
Right. It's actually hitting the air in the space. The air in the space is actually condensing onto the cold air that's exiting the unit.
Yeah, where it's not the relative humidity isn't high enough to cause dew, but it's high enough to cause fog. But if you're getting 55 degrees coming out of the discharge, 80, 67 indoor, yeah, you're probably looking at troubleshooting the system for potential refrigerant issues. That would be my advice. These systems they're not your father's heat pumps, They operate at a more efficient level. In heating mode, under AHRI conditions, which typically starts at 47 degrees outdoor and 68 degree, 50% humidity indoor, you could be getting 110 to 130 degrees coming out of discharge. I was in Oklahoma. It was 9 degrees outside. I think it was 50 or something indoors when we started the unit, and it was 138 degrees coming out of the unit.
And that depends a lot on the particular specs of that particular system. So you'll have some systems, high heat systems that will produce more, and some systems that will produce less. And the ambient conditions vary from unit to unit. But you're correct in that this range is going to give you a good general range to expect in heating mode.
I'm not sure if the discharge heat temperature would be any more than that. It could quite possibly be. But definitely some manufacturers have systems that can operate down into the negative teens, at 80 or so percent capacity. That's pretty incredible that with the software and what basically, ductless systems are is a computer, We're all familiar with the hardware. It's really the algorithms that are, and some manipulation of the compressor system that can allow for this. I mean, there are systems that can operate in cool mode at negative 40. We're in a good time right now to be in the HVACR industry. You're seeing all these advances. But the next one is find the root cause. I think that we covered that. Don't be a parts changer. You have anything to add to that?
No, I think we covered it. I mean, there's such a wide range of things that you can look at. And I think what you said about surveying the situation, knowing the job history, those are such huge factors, because if parts were just recently changed on this unit and you don't know what they were and why they were changed, that's where you get into these really frustrating loops where you replace the same board 3 times. We had a job recently that was like that, where it kept taking out boards. And even to this day, I could tell you about it, but essentially what it was is it was a 3-phase application. So it was a Delta system. So there was a high leg, and it was connected. One of the legs was the high leg connected to the unit. And theoretically, that shouldn't have been a problem. But for some reason, even though we were measuring proper voltages, I think just the higher voltage to ground was causing some shorting for whatever reason. I don't know if it was transient, something that was coming in. We were in Florida, so we have a lot of power issues. But every 4 or 5 months, we were taking out power boards on these systems. And so we ended up making a change and retapping the incoming power to legs that were not the high leg from the Delta system. Since then, we haven't had an issue. I don't know if you want to speak to that specifically, because I didn't find anything that you should do that, but that seemed to solve the problem. But that took really kind of being analytical and thinking, all right, what are all of the possibilities in this electrical distribution system that could potentially cause this?
There's plenty of times where you'll find yourself checking voltage, and maybe the system can operate between 187 and 253 volts, okay? 190, 250, something like that. You got to look on the nameplate for the manufacturer. And if you're operating at 250, let's say, and the high end is 253, that's not okay. Even though you're within the range, voltage is not a level signal. It can go up and it can go down depending on the day and depending on what's happening within the electrical system itself. If you run those high voltages, all your other components will be high too. So that 5 volt DC and the 12 volt DC, that's going to be higher. I think it's important to acknowledge that if you're constantly running high voltage or low voltage and you're burning out boards, you may need a buck booster. What a buck booster is a type of transformer that has taps, and you could tap it. You order it by the voltage and the amperage, and it's a box. It looks like 2.5 60 amp service disconnects stacked together. That's how big it is. And you can get the voltage to buck down, right? So if you're running high voltage, you could buck it down either 12 volts or 24 volts, and it will maintain at that level. So there's been plenty of times people are burning out boards and they don't know why. And I ask questions, are you near a factory? Are you on the outskirts of the grid? Do you have common voltage issues? Because the technicians usually know. The utility will never take blame for that. So if you're unsure about all these questions, you might have to put a data logger on there to record the voltage and catch it, right? Because if you're burning out boards, your customer is going to lose faith in you unless you take a greater step into an investigative process. And you can rent data loggers. Sometimes your utilities will loan you them. They have these expensive tools, and you set it up and you discover it. The buck booster is the answer. I've sold maybe 5 a year. And that's just me, just one person getting those calls. I mean, I'm sure if I took 50% of the calls out of all the state of Texas,
Right.
I may sell 100 a month. I don't know.
Right. And you make a good point, because a lot of technicians look at this and they're like, okay, well, that's not my problem. That's the utility, or that's the electrician's problem, or whatever. But anything that's taking out boards in your unit is your problem, because the customer views it as your problem. And there's a lot of people who would dispute that, but it's just the reality of life and business. Like you said, the power company, the utility, they're not going to take responsibility for it unless you can absolutely prove it. So you're kind of left doing that in some cases. And we've put those devices in the past. If you need to make small input voltage changes to a particular appliance, and that's good advice. Now, one thing I will mention quickly with ductless is a lot of guys will say, well, I put a surge suppressor on it. Well, a surge suppressor, first of all, the ones that you buy at Home Depot or whatever, they're not very good. If you look at the specs on a lot of consumer available surge suppressors, they're not great, and they're not really designed to protect super delicate electronics, let alone the fact that a lot of these issues are not due to surges. Surges are one set of problems that can occur, but if you have a constant voltage issue where it actually is coming in high or low from the utility, then a surge suppressor is not going to do anything with that. Surge suppressors are just designed to choke down transients, which are surges from lightning strikes or shorts in the actual distribution grid. The guys who say that they're going to use a surge suppressor to solve this, that's not always the right move.
No. The thing about surge protection is that you have a 20% chance of it actually working in the condition that you think it should work, like brownouts or lightning strikes. Because again, lightning strikes are very special in how they can destroy things, and it's very random. But the surge protection is just insurance, and that's how they should be sold as, not a all-covering solution, but just part of an insurance policy. If you're having voltage issues, the main thing is try to solve the voltage issues, whether it's a new transformer on the pole, or the utilities don't operate under the National Electrical Code. They can do whatever they please. They don't have to ground things properly or use the right ground gauge of wire. It's only after the connection from the house between the pole and your main circuit breaker box, and after the circuit breaker box is when your building inspector and the codes come into any kind of relevance. I spent a number of hours, I like to say 40 hours is probably more, on learning about grounding and bonding and signal communication and the importance. What's the difference between a shield and why you need a shield, why good ground is important. And so these are all subjects that are very, very relevant for ductless systems, because if you don't have a good ground, you're going to have a premature failure. Have you ever seen those little white spots on circuit boards? They look like little spider webs, or, look like salt.
Yeah, I have.
That's the manifestation of a bad ground. That's the radio frequency interference and the electromagnetic interference attacking the board because the ground isn't proper. It's very important, those subjects. Signal communication, grounding, shielding, and bonding.
Yep, for sure. And we could go on and on about this. I do want to get you back on and go over maybe some more like specific tips, maybe get a little more specific in some of this stuff, because you have a whole list of this as well. But step number 10 is to find the why. And that, I think, ties right into what we're just saying as it relates to finding the root cause. What causes this in the first place? Yeah,
so the ghost in the machine, what I like to describe as a conductor in a very sophisticated symphony, right? You could have up to, in a mini split system, up to 8 thermistors active, current transformers, pressure transducers, and the motors themselves. A DC motor is not voltage DC when they describe DC. They're actually describing the type of motor. A BLDC motor, a brushless commutative motor, and the digitally commutated, or DC, means that it just communicates. It sends voltage feedback. Just like an ECM, electrically commutated motor, it's a feedback device, and depending on the condition that the motor is operating in, it sends different voltages back to the circuit board, and that translates into some action or inaction. You have all these components being controlled by the conductor, or the why in things, which is the algorithms and the software. Once you are able to discover why the component is doing what it's doing, then the troubleshooting becomes all that much easier.
The point is that you have to understand, we think in terms of the inputs. So we say, okay, this is a thermistor, so test this thermistor. But what is that thermistor telling this brain that's driving everything, and what are the interdependencies? And that's where you can really start to become a master, especially if you specialize in a particular brand of equipment that you're installing a lot. If you have something that you're seeing a lot, it behooves you to understand it well and to go into the interdependencies and understand the whys.
I would say, because I've been to 7 different manufacturers' trainings multiple times. When I first started, I just immersed myself in this. What I find, there's a lot of commonalities in the programming. When I say ghost in the machine, it's like, what's making it do this? A lot of frustration for a service technician that's going to a service call in a ductless unit for the first time is like, what is going on here? In the conventional mindset, it's just on and off, right? You got relays, you got contactors, you got motors that have maybe 2 or 3 speeds. It's just on and off on everything, gas valves on and off. But with these systems, it could be neither on or off. And you're just wondering, why is it doing what it's doing? Well, it's programmed to do that. So if you could find out why it's doing what it's doing, then troubleshooting becomes much easier. And I'll give you an example. Typically, there's a sensor that's hanging outside of the condenser coil in the upper corner. And that sensor typically controls the fan speed of the condenser fan motor. Then you have another thermistor that's connected to high on the condenser coil on an elbow in a copper sheath, and it sticks in there. That typically controls the defrost. So once you can put together why these sensors are placed where they are and what they're expected to sense and relate to the printed circuit board, you'll be better off.
For sure. And truthfully, like, I'm in a position where when we started doing a lot of ductless, I was starting to move out of the field and more into the office. And so I have guys who are much better versed at what all of these things do than even I am. And when I look at a piece of equipment, I think the first thing is this curiosity that you had mentioned earlier, where you say, okay, I see this sensor, so what does it do? A good technician always wants to know the answers to those questions, even if it's not a unit that you've been particularly familiar with. And by pursuing that, you'll often find out more about the equipment than even people who maybe work on it every single day do, because they maybe have never thought to ask that question. Oh, I don't know. It's just there. It's an outdoor air temperature sensor. Well, okay, but what does it do? What is it telling the board? What is it telling the central processor? So it's interesting stuff.
A curious thing happens when you ask a lot of questions and attempt to understand the answers is that you become an expert at asking questions. There's plenty of times where I've been on a job site and I wasn't all knowledgeable, but I was able to ask the right questions and therefore build on that and come up with a solution or solutions. So
what I want to address real quick is a test that I did, because I think we kind of hit on, a lot of the technicians are frustrated by this whole, you just have to weigh in the charge thing. Like, that throws a lot of guys off. So we talked about the go and no-go temperatures, output temperatures. But another thing that I did that is kind of encapsulated in your tips here is I use the Testo 605Is and the Testo Smart Probes app, and you can actually measure the inlet, so your return temp coming into your evaporator, and then your outlet discharge temperature coming out of your air handler head, fan coil head. And you can use that tool, as long as you know your CFM, to calculate your delivered capacity. And then the only challenge is, of course, how do you find your CFM, which you can find that in some cases by just looking at the manufacturer's information. If you set your fan speed to, say, high speed manually, so you set it to high speed manual, then you can look at your chart and have a pretty good idea of what your CFM output is if the unit's clean, the blower wheel's clean. Or what I also did is I used a vane anemometer and actually measured the outlet of the unit and used my vane anemometer and came up with a very close semblance of what the manufacturer was saying. So I feel pretty confident about that output reading using the vane anemometer. And so you can, in some cases, use that. And that'll give you a good indication of whether or not you're outputting close to what the manufacturer intended for that system, so long as you're driving it to full capacity.
I saw that video.
Oh, you did? What did you think?
I thought it was great.
Okay, good. Ooh, I was worried there for a second.
I think YouTube is an excellent source of discovery. Of course, you got to check your facts, you can't believe everything that you listen to and see on YouTube, but there's a lot of good folks out there. And that particular video I thought was an excellent example of not using your gauges. I mean, you could discover the BTUs of a unit. If you have a 9,000 BTU mini split, and that's nominal, right? Nominal means that in AHRI conditions, these rated conditions, it's going to achieve 9,000, but it has a potential of being 3,000 or 14,000, depending on the atmospheric conditions of both indoor and outdoor. One of many great things about ductless systems is that you don't have to worry about static pressure, right? So if you read on the submittal sheets or perhaps even the sales catalog, you can discover the BTUs, like you said, set it to high, get your delta H, your enthalpy between the return and the supply, and delta H times the CFM times 4.5. Voila, that's your total BTUs. The gauges can't tell you that.
So I've been working a lot with Jim Bergman on his MeasureQuick app, and he's going to be working with different manufacturers with different sensors and different probes to do the same thing, or you can manually enter. And that's the nice thing about that is you can manually enter and find your enthalpy right there on the application. Saves a little bit of time even if you don't have the fancy software or fancy probes. Pretty cool stuff coming out, but I think that's the direction that we're going with ductless, is less relying on your gauges and more so relying on the actual delivered capacity on the air side of the system, which I think is kind of cool.
Well, I would say any air conditioning system.
True. On ductless, it's more critical just because you have less useful information otherwise. With conventional systems, you can always sort of default to the refrigerant side. I hate to call that lazy man's way, but you can always kind of go back to the old-fashioned way, whereas with ductless, you just don't have that opportunity. So using some of these newer techniques is going to be the way to go. And as always, most manufacturers with ductless, like I mentioned before, they want you, when you're talking about charge, to look at the actual factory charge weighed in. So weigh out, weigh in the charge. That's kind of the way they want you to do that. They don't want you just free-handing in charge. Which makes sense. It really is critical charge. And you may have a charge that's functional in cool mode. Let's say you overcharge it in cool mode. Well, that may be a significant problem in heat mode. So you can't just rely on one set of seasonal conditions to set a charge freehand. When I say freehand, just adding in refrigerant like you typically would on a unitary system.
Yeah.
With ductless. So
charging a system by pressure, any refrigeration system by pressure, is not advised. All refrigeration systems, whether it's a water fountain or a 10,000 pound a day industrial ice machine, are all critical charge.
Yeah, it's a hard sell getting techs to believe that, but yeah, charge is critical. So is everything critically charged? It depends on what you mean by that. Is the charge of every system critical? The answer is yes to that, getting the system charged critically. If you work on ductless systems, then you know they can be challenging to maintain. And if you don't work on ductless systems, then you're just going to have to take my word for it. The fin spacing on the evaporator coils are very tight, and even actually the condenser coil fin spacing is also tight. And then they also have these blower wheels that are really long, and the cups on them are just tiny, and they tend to gather up gunk over time, and they just stop working efficiently if they get dirty at all. They get any significant grime on them, they stop working properly. So the challenge is with ductless is how do you clean them? Because often ductless systems are, they're mounted up on walls in places that you can't get water all over the place. So how do you clean them properly? And one way you can do it is you can pull them all apart. You can pull the blower wheels out, but even then, if you do that, you still have to worry about how you clean the evaporator coil. So what do? Pull the whole air handler off the wall? Well, never fear. RectorSeal makes the Dissolve kit, and it's the word dissolve without the E on the end, as is very popular nowadays, and to omit the vowel. So it's a Dissolve, and it's a kit. It's also a cleaner, and so they have a cleaning solution that you can spray on the evaporator coil and blower wheel, but then it also has this bib that mounts underneath the air handler, or fan coil, whatever you want to call it, and you can actually use a wand to clean that off, and it all funnels down into a bucket. And what's nice about the kit is that because everything fits inside the bucket, so you just keep the bucket on your truck, you've got the bib, you've got the little drain that drains down into the bucket, you've got the cleaner, you've got everything all there in one place. So it's a pretty cool kit. Check it out. It is the RectorSeal Dissolve kit. Also, if you work on ductless, one thing that a lot of people struggle with is this idea of testing performance on a ductless system, because checking the charge is really tough on ductless. I mean, you can tell if the thing's flat, but other than that, it's tricky because there's so many moving parts. But what you can do pretty easily on most ductless systems is you can get a chart that shows you the different CFM output for the different stages of operation. All right, if you guys have listened to this podcast for any amount of time, you know that I kind of have a little bit of a crush on the Testo 605i. It's just a stupendous, can I say stupendous and not have it seem like hyperbole? I'm going to choose to say stupendous. It is a stupendous tool for the investment that you spend on it. It is a great thermal hygrometer. And for those of you who are like, what the heck is a thermal hygrometer? Well, let me tell you. A thermal hygrometer is basically a digital psychrometer. That's another term for it. And it measures wet bulb, dry bulb, relative humidity. Dew point, it can extract all of those. If you've ever looked at a psych chart, you need a couple pieces of information, and then you can extract the rest. But what the 605i does really well is that you can measure these readings in duct. So you can take wet bulb, dry bulb, relative humidity in the return, wet bulb, dry bulb, relative humidity in the supply, and right there in the SmartProbes app, it will actually calculate delivered capacity as long as you enter the CFMs, which is pretty cool. CFM. I always want to say CFMs, CFM of air. So the 605i is a great tool, but when you add in what Jim Bergman is doing with the MeasureQuick app, which you can find out more by going to measurequick.com/download now on that application. I'm excited about that product. But the Testo SmartProbes and the Testo 605i work with Jim Bergman's MeasureQuick app. And so you can get the best of both worlds, a really, really highly functional app plus the Testo 605i. So the actual SmartProbe app that you can use directly with the 605i, it works great, but you can extend its functionality by using it with the MeasureQuick app. And so getting delivered capacity is a huge thing. I mean, you can actually show your customer right there on your phone. We've already done this on many occasions. Like, look, this is how much capacity this system is actually delivering. Here's what you paid for. Here's what you got. It's a great product, and it's also just a great way to get your indoor wet bulb and dry bulb, which you need anyway if you're going to calculate superheat on a fixed orifice system. If you want to use it to calculate target delta T, air temperature split, it's also great for that. It's just a good all-around temperature measurement device, plus it gives you that additional data that you can only get from a thermohygrometer, and you have the ability to get it in the duct. Plus, it's Bluetooth. And like I've mentioned a million times, you can get that particular product, the Testo 605i, by going to TrueTechTools.com. And at checkout, use the offer code GETSCHOOLED, all one word, no caps, no spaces, GETSCHOOLED. Look at the bottom left-hand side of the screen when you're in the process of checking out there, and there's a coupon code box, and you type GETSCHOOLED in there, and you will get a great discount. All right, so anything else you want to hit at the end before we finish this up? Is there anything that's real important that you don't want to miss in this episode?
If you notice that this thing was really more of to get into a mindset, right? Because if you don't have the proper mindset or conducive mindset to finding a solution, all you're going to do is be frustrated. By the way, there's no such thing as inverter compressor. There's single rotary, twin rotary, scroll compressors, and what have you. But the inverter is the drive mechanism. An inverter is a DC to AC converter. Okay. A rectifier is the AC to DC component. So you're only getting half the story when people say inverter ductless system. It's actually a rectifier and an inverter. I like to throw that in so it helps kind of, again, demystify it all. Other thing that we didn't talk about is learn computer and electronics terminology, which is imperative, as conventional systems become more sophisticated. They're taking a cue from the ductless world and understanding maybe what a diode is. I'm not a proponent of troubleshooting circuit boards. Some manufacturers love to get into the weeds. When I say manufacturers, employees of manufacturers, they just want you to understand the level of how competent they are in their understanding of the systems. We don't have to do that. Power in, power out, but it's good to know some of the terminology. So if you're weak on understanding computers, that's going to work against you. The more terminology, the more vocabulary you have to understand the system, the better off you'll be at mastering it. Another thing here is 50% of the errors can be cleared by resetting the power. So that's good news. I wouldn't expect and I wouldn't advise people to walk up to a system that has error code, shut off the power. You still want to do your troubleshooting checks. But if it comes to the point where there's lag time between your phone call to the support agent and the phone call back or what have you, you can turn off the power and you want to wait at least 5 to 15 minutes, depending on the system, how big the system is, to let the capacitors discharge. And then turning on the power, and you got a 50% chance that the error code is going to go away. And that's because it's a computer. Computers have bugs in them. They have little burps of issues. And you may have ran into a situation where the system didn't know what to do, so it spit out an error code. And then that problem went away, but the error code remained. That's good advice.
It's just like a computer in that regard. I mean, when a computer locks up on you, something did happen, but that thing that happened may not reoccur for a very long time or may never reoccur. And so it's not to say that, I think when people talk about bugs, there's not an actual cockroach crawling around in your unit. I mean, it's not magic.
It's not magic.
Something did happen. My instructor in AC school used to call it PFM, which it's pure friggin' magic without the friggin' part. PFM does not cause problems in these units. However, sometimes there's small voltage inconsistencies or little things that can happen that don't reoccur. And when those things occur, it may lock out on a code, and that code may reset just by resetting the power, just like it does on your computer. So in the same way that you would reset your computer sometimes when things start getting sluggish or acting odd, you would do the same thing with any device that has a significant amount of electronics in it. And often that does solve the problem.
Exactly. The next thing here is 50% of the service calls are building science related. What I mean by that is the envelope of the building is affecting the performance of the system. The more you can understand about the thermal envelope and it's connected to the whole system, the whole, cooling and heating system, the better off you will be, because a weak building structure or subpar or inferior construction materials will certainly affect the occupant's comfort level. There's been plenty of times where I've experienced a system that, for example, maybe spitting out water, okay? And you're going to go through your trouble checks and there's no error code for spitting out water. Well, what's happening is that there's a tremendous amount of infiltration, where basically what's happening is that the humidity is at such a state in the space is that as soon as that cold air hits a part of the unit's casing, it wicks and boom, you got spitting water. So that wouldn't be the fault of any particular manufacturer. It's a building issue. Does that make sense? Do you have any examples?
Sure. I mean, a common example would be, this is actually an installation problem, but we see issues with ductless systems that occur if it's an exterior wall and the penetration where the copper goes through the back of the exterior wall isn't fully and correctly sealed. Because now that's going to act as a straw, drawing in moisture that will result in all sorts of gunk all over the place, mildew and all sorts of other junk. And that's not the problem of the unit. That's the problem of the fact that you haven't sealed the envelope properly.
Yeah.
And then lots of other applications. I mean, obviously, load is a huge thing. If you have a system that's in a circumstance where it's vastly oversized for the load or undersized for the load, those are obvious factors. But then also the humidity design of the space, another huge consideration. So you have to take all of this into account. It's still an air conditioning system. It's not magic. And so it has ranges of operation that are generally better than its unitary counterparts, but
it has limitations.
Sure, it has limitations, just like any piece of equipment. Yeah. So you have to know the application and make sure that you're matching it to the application. I mean, there are cases, like if you look at Mitsubishi makes a ductless 6,000 BTU head that matches up with their MXZ, and if you look at the specs on that ductless 6,000 BTU head, at design conditions, it removes 0 latent, meaning 0 pints of water, none. Because of the way that it's set up, because it has the exact same airflow characteristics as the 12,000 BTU version. And so it's producing the exact same airflow at less BTUs of capacity. And so therefore the coil's just not getting cold enough. So if you take that and put it into a room, say you put it into a closet that you're designing this closet to keep your clothes from getting mildewy or whatever. Well, if you put that in that walk-in closet, you're going to do the opposite. You're going to make that room into a mildew cave with that unit because it's just not designed. That particular unit is designed for 0 latent removal. It says it right in the specs of that particular unit. And I actually pointed that out in that video that we discussed earlier. There's lots of different, you got to know the equipment.
What's interesting about the 6, 9, and 12 in that case, it's the exact same system, exact same components. It has the same CFM value. It doesn't show the pint removal on the submittal. I haven't read any verbiage, though, where it actually claims or states that it doesn't remove latent. But The difference in those three units is the circuit board part number changes. In my mind, I just don't think that they tested that unit yet or something.
Sure, it could be, but you clearly know that if it is a 6,000 BTU head, unless it is, because what the circuit board's doing is it's telling the electronic expansion valve to feed less refrigerant into it. I mean, that's the only thing it could possibly be doing. So if it's not doing that, then their capacity ratings are incorrect. Either it isn't doing latent removal or something's wrong in the way that they tested when they printed that sheet, which is altogether possible because I haven't physically tested it. But just going strictly on what the manufacturer's telling you based on those design conditions, that would not be a good match if you're intending to put a 6,000 BTU in a space that you're wanting to remove a lot of moisture out of. That just wouldn't be the best design unless you got some confirmation that it's different than what they show.
It would have to remove some latent, your sensible heat ratio has to exist. You would discover that by doing your total enthalpy check and then your sensible check, and what between is your latent.
Correct. And you do that through testing. But again, the reason why you would remove no latent would be is if your coil temperature was above dew point. If that coil temperature at those airflow ratings, at those CFM ratings and the capacity, because that's how that works, obviously, is that if your capacity, the BTUs.
If you have a wet coil, it's not going to operate correctly. It's not going to remove latent. You need a colder coil. You need to be below dew point.
Correct.
If you're at or above dew point, that's problematic. But
right.
What I'm saying is that on that particular model, let's say that you have a MXZ 8B or 8C, what have you, and you are running your max capacity, which is 135% total indoor unit capacity compared to the outdoor. And the 6,000 is the only way you can go, well, then that's your answer. But if all the other units are off, that particular 6,000 BTU unit has a potential between 3,000 and maybe 10 or 11,000 BTUs, depending on the temperature. And that can be discovered of the space. And that can be discovered by the capacity charts. So the higher humidity, the higher the BTU potential you have. So the next thing is building expectations with the customer. If you think a job is going to take an hour, schedule 3. So you can tell Mr. and Mrs. Jones, we have worked on plenty of ductless systems, and we know that it's going to be a minimum of 3 hours to properly diagnose the trouble and find a solution. And the reason why I do that is because when you show up, you're not going to have the manual, most likely. And you're going to have to call a buddy or call a manufacturer. And you give yourself and your company some time to do a proper job, maybe clean the coils. Whereas if you just charge a service call, it's probably going to be a losing venture for you. Will you lose jobs to other folks that haven't heard this podcast or this advice? Sure, but don't lose money. Everybody in the industry should be making money because we're the doctors of HVAC. We're the professionals. When you build those expectations and manage those expectations, things start to get a lot better working environments. The last two here, where is the worst place to put a condenser? It's on the roof. When you have the sun beating down on it, you lose capacity, because your roof temperature could be 10, 15 degrees difference between the street level temperature. And that's going to lower the capacity of the system. When you add heat to a motor, it makes it less efficient. Add excessive heat to a heat exchanger, it's going to be less efficient. There are plenty of applications where I've seen the outdoor units inside of a garage, which is great. If you can get the ventilation of the garage to be equal to the CFM of the condenser fan motor, then that system will run just fine. They're very, very quiet. They don't vibrate. And you just get a louver size, right? Like, for instance, if a 1.5 ton outdoor unit has a maximum CFM of 1800 CFM, then just make sure you have 1800 CFM worth of ventilation in the garage to have that air exchange, And the benefits of that is that the unit will last longer, right? In heat mode, you can lower the defrost cycle and increase the performance because it's typically not going to be snowed on, or in the wind chill factor will be eliminated. So that's beneficial. And in cool mode, a garage can be a lot cleaner than an outside with your dog and all the other things that are outside that can affect the condenser coil. There are VRF applications that I know of where you have 500 tons worth of condensers inside of a building. And I say condensers, they're heat pumps, but it's just outdoor units. And they have maybe one or two 2,000 BTU unit heaters in that space. And the unit heaters are set to come on if the temperature is below 50 degrees, then it's going to come on and work until like 55 degrees or something. Protecting the condenser, putting in the shade, very helpful. Then the last thing is verifying the application. Like a wrong application is a pretty high or common factor with these systems. For instance, in a computer room, I'm not going to stop this from happening, but a computer room has a constant load. If anything, the load increases over time because they're adding more servers. So winter and summer, the load stays the same, relatively speaking. And the whole purpose of an inverter-driven compressor is to save money when the load changes, right? The part load savings, right? So if you look at Data Air or Liebert or Stutz, those are maybe 1 or 2 stage compressors, right? And it's all about very specific temperature, maybe 70 degrees set point plus or minus 2 degrees, and 48% relative humidity plus or minus 4%. Not 4% humidity, 4% of 48%.
Got it, right.
Relative humidity. And when you have conditions like that, that's not for ductless, because ductless systems typically don't cycle on humidity, right? They're not there for latent control. So you want to spend the money on getting the proper equipment. A server rack can quite easily cost $50,000. And you want to put a $3,500 mini split in there, protecting $50,000 worth of equipment. Or a business operation, can the business survive without a server system? Probably not. And I read somewhere, and I've had trouble trying to find it. If somebody can find it and email you, that would be great. But I think ASHRAE or some institution published years ago on a crack application, a computer room air conditioning system, the budget should be 30% of the value of the equipment. So if you have $100,000 worth of server equipment, then you want to spend at least $30,000 on your cooling equipment. I think you'll be able to get a redundant air conditioning system for that. So you have 2 systems.
Yeah, I worked in cell phone tower applications for a while, and those were all redundant systems. And it makes sense. I mean, at that point, when you have a lead lag redundant system, it's not so much about efficiency. They're not so concerned about how much power are they going to consume. They're much more concerned about the reliability of the cooling equipment and the fact that you have a backup that's going to work when the time comes. So I'm with you on that, because most ductless system, traditional ductless equipment, isn't really designed for that type of redundancy anyway. The controls aren't really designed for it, because you want systems with lead lag controllers that one runs and then it's running lead and the other's running lag, and then after a week or so it switches and they switch back and forth, so that way they're getting consistent run times as well.
That's right. But typically we're faced with a IT guy that has 0 power over the budget, and they call you and you got to go out there and figure out what the tonnage is. You're not talking to the right person about this conversation, so it's unfortunate. But I think this last thing that's left here, Brian, is are wine rooms a good application for inverter ductless systems?
Okay.
What would you think?
What do I think? I don't know that much about wine rooms. I've done, I think, 2 or 3 that I've been personally involved with in my career. And I think the answer is no, because wine rooms do have a relative humidity element. And if I remember correctly, I think wine rooms require higher relative humidity so that you don't have cork drying. Am I correct on this? Am I on the right path here?
Yeah. So in wine rooms, typically the white wines need to be in a drier area and the red wines in a little higher humidity. And again, anytime you hear specific temperature and humidity, that's not for ductless. There are plenty of websites and folks out there that you can go buy wine room systems that are specifically designed to handle the type of wine room. But the wine rooms that I've been in, the millwork and the wood species alone took a craftsman a year to make and $150,000. That's just the wood. You can imagine that some of the wine might be priceless. I don't know. So having the correct application of whatever technology that's going to serve that space is key to a long-lasting, well-designed system. If you dry out the corks, what's going to happen is the wine's going to leak. If you have too much humidity, you can get gnats. You can create mold on the wood that's used, because typically there's wood in the wine room walls. So no, a ductless is not for wine rooms. The reason why I mentioned that is to talk about the lack of humidity control with ductless systems, but also acknowledging that different technologies go to different applications. And there is a difference between design and application. And it's good to acknowledge the difference and understand the differences.
Good stuff. Well, John, I appreciate it. I thank you for taking the time. I thank you for doing this, and we will certainly do this again sometime.
Okay, will do. Thank you much.
All right, sir. Something that's been emerging lately, it's in the Unified Mechanical Code, and then a lot of local municipalities are starting to enforce this, is the idea of tamper-resistant refrigerant caps. And this is to prevent the theft and abuse of inhalants, primarily the abuse. Young people using refrigerants as a means to get a quick and easy high. And so it's a serious thing, and it's something that is emerging. You're going to start to see codes and local municipalities enforcing this. So what I would suggest is go ahead and start to get some no-vent caps from RectorSeal on your truck now, both on your installation crews and on your service vans. If you have to put on new caps anyway, maybe start using no-vent instead of the typical caps that you've been using. A lot of guys will point out, well, I don't want to have to keep that tool on my truck. Well, you're going to have to keep the tool on your truck anyway, because if your competitors use the no-vent caps, then you're going to need to have the tool anyway. And RectorSeal makes a nice little keychain key that you can put right on your key ring, and that way you've got it. And so once you start to use them, whenever you have cases where you've got caps that don't have seals, you can offer them to your customer as an upgrade. You can install them, and then it reduces the theft and the risk that an adolescent, especially, it's mostly young kids, are going to abuse the refrigerant as an inhalant. So that is the RectorSeal no-vent caps. You can find out more by going to RectorSeal.com. Hey, thanks for listening to this episode. If you're listening to this in mid-September, I recorded this before the hurricanes hit, Hurricane Irma. So I have no idea what happened after this, which is sort of an ominous thing. Like, I'm recording this, and within a couple days, we're going to get hit by probably the biggest hurricane I've ever been hit by in my life. Currently, the track is literally going right over my house, the projected track. So it all may be good, and then you may never hear about it again and all that kind of thing, or it may be really bad, and I may not be releasing podcasts for a little bit. Who knows? But one thing that I want you to know is that, oh boy, this is going to sound kind of emotional here, but I've never regretted working in this business. It's a really, really great business, and it's a business that deserves great people, and great people who have the recognition from the country, recognition of what we do every day. And so I'm talking about HVACR, but I'm also talking about the trades in general, electricians and plumbers and welders and all of you, and who are out there working with your hands. And so the Blue Collar Roots Network is an homage. It's paying respects to the men and women who have worked their entire lives, maybe without the respect they deserve. Let's face it, I don't think blue-collar workers get the respect that they deserve. But, truthfully, most of the blue-collar people who I've known, they're not out there looking for respect. They're out there working, fixing problems, building things, and taking pride in the work that they do every day, the real good ones. But you and I have both seen a lot more forces of people who come into this trade who don't care about what they're doing and are just looking for either the quick buck or they're looking for the job that they can do because they can't do anything else. And that's sad. I want to see the brotherhood and sisterhood of people who work in the trades come back. And that's what the Blue Collar Roots Network is. We've got a lot of good quality podcasts that are going to be coming out, kind of moving forward the trade with good quality people and having this sort of broader conversation. It's not just us talking into a mic. The conversation that I had with John Chavez, for example. You build relationships with people doing this, good people who want to do things the right way and not perfect. There probably isn't a podcast that goes by that I don't say something dumb. We all have things that aren't perfect about us, but good blue-collar people are the kind who want to do a little better every day, a little better than they did the day before. They want to do good by their customers, want to do good by their families, care about America and their kids and their wives and their parents and their husbands. It's that sort of thing, and I think a lot of you who are listening feel that way, and I'm glad you're here, and I hope that you will check out the other podcasts in Blue Collar Roots, The Tradesman with Zach Ciota, HVAC Shop Talk with Zach and Ralph. We have a couple others coming out. The HVAC Building Science or Building HVAC Science podcast with Bill Spohn. You'll find that out there. We've got the Tool Pros podcast with Billy and Brent Ridley, Billy Knopf and Brent Ridley, that I think you'll enjoy. And then we've got Tersh Blizet and Service Business Mastery. So those aren't necessarily all out right now, but they all are coming very soon. So I was talking to Stephen Raridan the other day. He's got a YouTube channel on YouTube, which you should check out. And I was asking about his beard, and he said he didn't like his beard at first, but then it grew on him. We'll talk next time on HVAC School.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.